All right, so look, I want us to look at another problem, which is probably going to be the last one for finding the gradient of the tangent and the equation. I think these are pretty straightforward problems. So last one, we've got let's just call it g of x is equal to 1 over x, and I'm sure you guys, I mean, the g of x is the same as x to the exponent -1, so you already know that we need to, so this is the same, we must find the gradient at x is equals to 1, and obviously that means that we are going to then do this, find g prime of x, which is what, minus x to the exponent -2, right? So we know that this is the gradient, okay, but what is the actual numerical value of the gradient? That's when we substitute x equals to 1, right? Because this is just an expression for the gradient. So g prime at 1 is equal to minus, and then 1 to the exponent -2, which is just -1. Okay, so now that we've got the gradient, you know, obviously when we are using this formula here to find the c, we need to find what? We need to use a point, right? So we're going to substitute this into the original function g to find the corresponding y value. So g of 1 is basically 1 over 1, which is 1. So therefore our coordinate is 1 is to 1, right? So let's substitute 1 is to 1 into this function here and find the c. So 1 is equals to -1 plus c, and therefore c becomes what? 2. Okay, and if c is 2, therefore y is equal to minus x plus 2. So that is the equation of the tangent passing through the point 1 is to 1. Understand? So this is the equation of the tangent to the function g of x. So I want us to shift, the conversation a little bit, right? Remember we dealt with the function. Let's call it k of x is equal to x squared minus 2x plus 3. Okay, we'll dealt with this function already, okay? And I want to show you something, because normally this is what we do. Like, I want to show you the applications of the first derivative, okay? Very, very important in calculus, this application that I'm about to discuss with you. So you know that to find the turning point of the graph, you'd have to do this: x equals to minus b over 2a, and you know the b is -2, the a is 1, so you know that definitely the turning point is going to be at 1. And to find the corresponding value of the turning point, then you'd say, okay, let's substitute this 1 into the original function k of 1, that's 1 squared minus 2 1 plus 3, and that gives us what? So that's negative, that's 2. We've got 2, so meaning that our turning point is at 1 is to 2. Okay, that is our turning point. So now there's also another way of actually finding the x coordinate of the turning point using the first derivative. Okay, so this function looks like this, and you know that this is our turning point, and at our turning point the gradient of the tangent is equal to 0. Do you understand? Why? Because this is a straight line, horizontal. Do you understand? You can have many other tangents like that, but they're not 0. They've got, their gradients are not 0. So they've got, so there's the tangent there, there's another tangent there, there's another tangent there. All of them, their gradients are not 0. In other words, m is not equal to 0. It's only at the turning point that the gradient of the tangent is 0, right? So write this down. At the turning point, the gradient of the tangent is equal to 0. But what is the gradient of the tangent? I hope you said k prime of x, or first derivative, right? That's the gradient of the tangent. So meaning that if you want the x value there, right, that x value there, you can use the fact that k prime of x, which is the gradient of the tangent, is equal to 0. Okay, and k prime of x, that's obviously 2x minus 2. It's simply the derivative of that, k prime of x. So 2x minus 2, right? So we set it equal to 0. Remember, at the turning point, the gradient of the tangent is 0. So 2x minus 2 is equal to, so we're now solving for x. 2x is equal to 2. And x is equal to what? 1. The very same value that we got that side. So after getting that value, we can then substitute what? We can then substitute it into the original function, which is k of x. So k of 1 is equal to what? 1 squared minus 2, 1 plus 3. Remember what we got when we were substituting k of 1, right? We got 2. So meaning that even here, we want to get 2. So we still got 1 is to 2, right? So obviously, you would rather use that formula there, you know, when the quadratic function is concerned. But immediately when you start dealing with a function like this, let's say q of x is equal to 2x to the 3, right? X to the 3, and then plus let's just say minus 2x squared, and then minus let's just say plus 24 x plus 18 is equal to 0. Not equal to 0. Let's just say we're dealing with that function, and that function is a cubic function. It's like this. It's like this. It's got 2 turning points. Alright? It's got 2 turning points. And normally what they're going to ask you in calculus is that they will ask you to find the turning point. A is to B. C is to D. They'll ask you to find those turning points. And you don't have any other way except using the first derivative application, that at this point m is equal to 0. M is equal to 0. And in calculus, when we say m, we're referring to the first derivative, right? F prime of x, g prime of x, q prime of x, whatever. That's what we're referring to when we say m. That's the thing that you need to, you know, grasp right now, that the gradient is basically the first derivative. So we can then find the gradient, right, the m, and set it equal to 0, the same way we did on the previous problem. So we need to derive this problem, right? Obviously, we're going to start off by deriving 2x cubed, which is going to become what? 6x squared. So q prime of x, 6x squared, right? We multiply the 2 and the 3 there. We minus the 1 from the 3, and then the second one, that's 2 times the 2, which is minus 4x. And then 24x, that becomes plus 24, which is equal to what? Which is equal to 0. We set it equal to 0. Why? We set it equal to 0. Why? Because we want to find the x value whereby our gradient is 0. And once we've got the x value, then we can go back to the original function and find the corresponding y value. So, but notice that there's a 2 at the top, right? There's a 2 at the top, meaning that there's 2 x values. One x value is at the first turning point, the other x value is at the what we call at the second turning point, right? So obviously we will need to use the quadratic formula here to find our x value. So we've got 2x squared, 3x squared minus 2x, right, plus what? Plus 12 is equal to 0. All right, is equal to 0. Yeah. So I just came up with this with this equation. So obviously in this case we can't really find the x values, but let's suppose that our q prime was actually x squared minus x plus 12 is equal to 0. Then we know that, okay, we've got x, right, 3, 4 minus plus is equal to 0. Then we know x is equal to 4, or x is equal to negative 3. Yeah, we're just assuming here that our q prime of x is that, right? Because this one doesn't have any real roots. Okay, so once you've got this, you take the obviously the negative 1 is going to be that one, so negative there, and here it's going to be 4. Do you understand? Right? Because the first root, which is smaller than the second root, is going to be on the far left, right? And then the second root, which is bigger than the first root, is going to be on the far right, right? So yes. So now let's go back to our function and then we substitute. So we go back to q of x, right? Not q prime of x. Q of x we substitute 4, and then we also substitute minus 3, right? And then so 4 cubed minus 2, 4 squared plus 24, 4 plus 18, right? And then here 2 into minus 3 cubed minus 2 minus 3 squared plus 24 minus 3 plus 18, right? And then punch everything to the calculator and we get the y values. So just a second, we're trying to figure out what is the value there. So let's check what value we're getting, right? So 2 times 4 cubed, right? 4 cubed, and then this calculator is so slow. Minus 2 times 4 squared, right, plus 24 times 4 plus 18. So you can see that it gives us 210 here, and then the other value is minus 3. So 2 into negative 3. Very important to use brackets when you're dealing with negative values, eh? 2 into negative 3 cubed, right? And then minus 2 into negative 3 squared and then plus 24 negative 2 plus 18. Right, so we're getting minus 126. That's what we're getting. So now we know, okay, the turning points are going to be at 4 is to 210, and also at minus 3 and minus 126. So those are the two turning points. So we'll dive deeper into this as time goes by, but this is just a quick intro into finding the turning points, right, of any cubic function, because you guys are going to be dealing with cubic functions quite extensively. So yeah, don't forget to like, subscribe, and share with your friends and family. Whoever might need this, please share with them. And shout out.